I'd like to present a presentation which has been created for Slovak companies. And the topic of the presentation is how to sustainably increase production efficiency. Presentation and project is supported by the New DNA project, which is an international project supported by the European Union. You'll tell about continuous improvement. It's the same like how to improve the business and to achieve better results. If a company is going to be transformed to digital backbone, there are some key factors. Next session is about what to focus on. Our 3 initiatives, I can say. 1 is customer experience. 2nd is operational excellence. And 3rd one is new business model. There are 3 basic areas of digital transformation in industrial companies. This presentation, we would like to discuss more about operational excellence. What means 3 steps? First is data acquisition from a lot of resources like machines, processes, people, and horizontal and vertical integration. 2nd is business analytics. So if we have data, we would like to switch them to the useful informations. And these informations will help us to find opportunities for improvement. And the 3rd one is automation of this process and standardization. So if we have some process, or if we have developed some process how to collect the data, change them to the information, the very important is to standardize this approach and to use it in the future in the company. It is not a one-time business. It's continuous improvement. So first, we would like to discuss about data acquisition, what is possible, and what typically small and medium companies need. So by research, which we have realized in a lot of small and medium companies, there are some basic needs, which we can split to needs of top management and needs of middle management. Top management is mainly oriented for business and results. So concrete questions are, what's the real profitability of why not possible to fulfill the production plan? Why it's not possible to meet deadlines? And so on and so on. And middle management is oriented especially to equipment and how to have equipment as utilized. As so the questions are typical. What jobs are operators currently working on? What jobs are machines currently working on? Are the reasons for downtimes or breakdowns? Or how to distribute the work between machines operators to achieve the best possible results? We want to get answers to these questions, and to help the management to make good decisions must go typically through this process. First one is about data collection. Second, if we have data, we must process them. A result of this processing is the best, as simple as possible information input for good decisions. But if we want to have benefits, I mean financial benefits or some other benefits, it's necessary somebody from management must make a real decision that something will be changed based on the data. If this decision will be made, it will bring benefits in the but without people's decision to change anything, no benefits can be expected by our experiences. We're going to transfer data into informations, are typically 3 views to the informations. One is current or online. It's typically visualization, monitoring. This is showing what is exactly happening at the production or logistic or some other process. So it's something like online visualization. So it is view to the current state. The second, our reports, are typically view to the past. So there's some historical data. And I would like to find some troubles or some problems or some downtimes from the historical data. So it is view to the past. And third possible view or applications, it's view to the future. So there's something like predictive or proactive applications. But these applications are typically not possible to realize in first stage of digitalization because you must have or company must have some experiences and, of course, some data. But it's possible to have it or to provide it in phase 2 plus next phases of digitalization. And typical predictive applications are based on the data, but view to the future. For example, plan optimization, it's typical predictive or proactive applications. Predictive maintenance, predictive quality applications, predictive logistic, they're all applications which are based on the data and knowledge about what happened in the future. The base of this, you can predict and or proactive control to the future operation. What's the current status of digitalization in small and medium companies? Industry Forum, which is part of the project for Slovakia, made some research or doing some research many years. And this is a very important output. This chart is showing which companies have some strategy or plan how to digitally transform themselves. So as you can see, at the year 2021, 125 companies responded. From these 125 companies, just 26%, so it's one quarter, has something like plan how to digitalize or how to digitally transform the company. 2022, it's very similar. And 2023, it was little, just very, very few improving. So practically, we see that small and medium companies would like to transform themselves, but they have no plan. Or just only some companies have some plan how to digitally transform themselves. So if you have some digitalization plan, you can force these questions or these issues or challenges. Typically, if you will take state of the digitalization of the small and medium companies, in most cases, companies would like to digitalize, but they don't know how to do it. Second challenge is they can't imagine the specific results of digitalization, especially for themselves. Also, they don't know exact technical possibilities, for example, how to collect data from machines, and so on. And based on this, they are generally afraid to invest in digitalization. Of course, there's also some other challenges, as you can read, but these topics are making companies to be very careful about investment to digitalizations, and especially small and medium companies. And by this presentation, we would like to break the ice because we would like to show also some practical applications and results, and also some technical possibilities to obtain the data from production and processes. General overview and our recommendation to digitally transform is showing on this picture. So first, connect people. A very big mistake if some, for example, manager will tell, we will digitalize this, we will do that without discussion with the people because the people are sources of information. So first, connect people from many departments, from many initiatives, and find a common language. It is very important to speak by the same language and to understand the problem by the same way. Then, next step is to find opportunities how to improve the business. And after this, really rethink ideas. This is the best approach in implementing smaller pilot projects. Based on these pilot projects, evaluate results, and based on evaluated results, correct the project, and then deploy the project to the other company's department or other processes. Is the best approach in how to digitally transform the company. So practically, what are the options for collecting data from machine processes? If somebody would like to collect data, in Surrey, there are typically 5 initiatives which should be solved. First one is technical, how to map data symbolically to signals from production or logistic. Then, how to transfer them, how to storage and process them, how to connect the data with other systems, and how to convert the data into useful information. Today, at small and medium companies, there are a lot of different technologies. So we can discuss about how to connect data from production line, which is controlled by PLC, CNC machines. It's a special kind of which is also necessary to obtain the data from. There are also other machines where there is no automation, but we need data from them. Manual operations, like for example, assembly process, welding process, it also should be monitored. Moving objects, especially logistic, is a very big challenge for digitalization. So there's some material movement or tool movement, equipment movement, vehicles movement. Then there's some other information about, for example, temperatures and other physical measurements, which can be covered by, for example, IoT sensors. And then there's many other equipment like production logistic terminals, smart devices, industrial PC, and also important part is energy monitoring. So if a company is going to digitalize, it's recommended to apply this digitalization to all processes which are important of the company. And it can be mixed from these data resources. The second one is how to transfer the data. Of course, it depends. If there are fast data, slow data, important data, less important data, but practically it is by cable. So some industrial communication, Profinet or Ethernet, or some wireless communication, Wi-Fi, RTLS. It's real time location systems. It's something like GPS in a production facility or some IoT communication using IoT network. Next one, very important, how to storage and process the not big data can be stored also in standard SQL database, for example, Microsoft SQL. But if we're discussing about large data, the SQL is not very suitable for this. And in this case, we should do some historian-based database, which is specially prepared to store industrial big data. And if you have data collected, and it's typically necessary to connect it or interconnect it with other company systems, like ERP, for example, mass systems, or warehouse management systems, or some other systems, because it's important to put the data just once and use it as much as. And if you have data we have discussed, they can be viewed to the past, viewed to the present, and viewed to the so in the past. There are, for example, downtime types, OE, bottleneck causes, real-time data. They are typically dispatchings, production dispatchings, logistic dispatchings, or specific visualizations. In future, they're about optimization, production optimization, logistic optimization, or some predictive applications, like, for example, predictive quality, and so on. Automatic data collection is very important because it eliminates human mistakes. So if you will look at the picture below, is explaining why the automatic data collection is important, because in technology, there is some plan or wish, there is some preparation time and production time. If operator will start and stop the operation, you will see just start operation, stop operation, and nothing in the between. But if this type of data will be with automatic machine monitoring, you will see that there are some standby mode, working mode, standby mode, missed errors, and so on. And if you will combine this data, you will get very important information. For example, net production time, gross production time, what is very important for efficiency of the concrete production order. With data to collect from, I can say, basic standards like this. So the best start with the basic status is run, ready, error off. And if machine are telling automatically it is ready, somebody should get information why it is ready and not working. So for example, you can see examples from the projects. So it's better specification of the reason of downtime. The similar it is an error. And then, especially more expensive machines be used for data collection, not only basic statuses, but for example, other informations. Like for example, technological parameters, some speeds, temperatures, and so on, as you can see at the table. But of course, this data must have some reason collecting them. Without using this data, we don't recommend to acquire large data from machines, because large data means large databases, large servers, and more complicated evaluation. So it's very necessary to understand what will be outputs and for which outputs data should be used. We are discussing about automatic data collection. There are more options. Best one is for modern machines up to 10 years old, maybe in some cases older, when it's possible to use communication standard OPC UA. OPC, abbreviation, means Open Protocol for Communication with Architecture, which is European norm. It is also yin something. And this is service which is provided by the same way by any vendor of machine. Second option is digital signal mapping, as you can see in this example. So digital signal will tell us if machine is in working mode or in waiting mode or error mode. Is very similar to this Y data transfer, but this is wireless. It is IoT, but it is very similar to this PLC. This is IoT digital sensor. The last one for old machines, or for example, manual machines like welding machines, there's also possible to data acquisition based on the consumption. As you can see, the electrical consumption, sorry. So this is the detail, for example, how to connect also older machines. So we have proper digital inputs. So galvanic splitting, we will transfer that to PLC. And from PLC, we have from signal real data or data processing. So typical architecture of the project is that you have a lot of production equipment with different vendors, different operating systems, different possibilities, but you must do standardized data acquisition. You can see there are some special protocols, Siemens using S7, Fanad using Focus, Heidelberg using DNC, and so on. So it's necessary and important to get the different way, but is stored in a unified database, which is then processed by an application, and the outputs are, in this case, in this project, visualization means real-time data or reports due to the past. Sorry. Which production information is important to have for making the right decisions? It's also a question because typically top management has different requirements to mid, management, and operator is also different level. So we are able to recognize 3 levels, top management, mid, management. Top management is interesting about net production time, gross production time, and comparison plan reality. So it's about business. Mid, Management is about how to maintain the utilized as possible, so there are causes, downtimes, failures, how to best distribute the work. An operator level, it's very important to see by each operator. What's my efficiency today? Real time view. Pairing a specific order with automatic data collection for machines and more detailed specification the downtimes and errors. Examples. Information for top management. So profitability. Based on the data acquisition, you can see very simply output. So from many machines and processes, data are collected, and you're able to see net production time of the order and gross production time. So it is net production time plus downtimes and errors. This is the different view, the same output. Based on this information, you're able to do analytics and in the future prepare proposals better or to identify which orders are profitable and which orders are not profitable. So if you'll compare it, you have a very simple output. For example, contract plan, what has been planned, what operator told us, and what machine told us. So a comparison of this information brings us a very good view to the efficiency. We are also working on AI evaluation of the data, which should help the managers better understand the data and also to get information from large databases by a very similar way how that, for example, GPT is working. So ask questions, retrieve the data from machines, processes, and so on, and answer to the requested question. Information to the middle management, maximizing utilization of the resources. So first view is what is really happening. So you can see each machine is automatically monitorized. So you can see what is machine doing, which worker is working, which contract is working, gone efficiency of T machines, per contract, per shift, per day. So shift leader is able to immediately see if something is going bad. If I want to have some more detailed information, I will just click on the machine and I see the time view of the machines and statuses, which has been automatically acquired from each machine. It was visualization or dispatching, and then there are reports, view to the past. So this is, for example, monthly view of efficiency of a machine, and you're able to see how much time machine worked, wait, or had some other statuses, errors, setup, switch off. It is very good view or overview for each machine. The next important information for each machine is productivity. Green line showing the net production time. So program has been running. So you can see it is first day, second day, 11 months, and so on, and this is average, and this is my wish. Of course, you can analyze, for example, why this machine has been not very efficient here, but you're able to see what's the efficiency for each machine. In scene 1, basic information about machines are metrics or a table, all machines and all reasons of downtimes, errors, working times, and other downtimes like setup time, switch off, and so on. And the next one is operational level. So operator is able to see on production terminal, what's my efficiency for the current order? So the green lines show that my efficiency is 37% and 63%. There were some other statuses like errors, waiting, and so on. This is program round. It's very important to see by each operator because it is motivational for them to be productive. Operator also change over the production. So when he's starting new production order, he will tell I'm starting new production order, and from this time, each status of machine is linked with this new order. In the scene 1 activity is specify the reason of downtime or error from unspecified to some reason from list, for example, waiting for logistic bed drawing or something like this. Based on this information, it's possible to identify the reason for downtimes. And if I'm able to identify them, I'm able to find solution how to eliminate this type of downtimes. So I'd like to show at the end specific applications for small and medium companies, some project examples. Project is custom production, custom manufacturing, and the bottleneck has been welding shop floor. So we have prepared solution. We have prepared something what we call the digital twin of welding shop floor, where we teach the system behavior the same like the physical system. So as you can see, this is the example of the digital twin, and it is connected with the so this digital twin is automatically adjusting the welding people with experiences to the product, and it's automatically putting working orders to the so result of this is helping to shift leader to distribute the work for the next shift. As you can see, there's list of order and it is like a very useful calculator, which is calculating all possibilities and try to find the best steps for production. And if shift leader will use these steps, he will achieve the best result. Of course, he can make decision by himself, and next shift or next day, the data are automatically collected, and this shop floor is again evaluated and recalculated because, of course, something has been postponed, something has been realized, and so on. So based on the reality, the digital twin is automatically compute the next shift or next day. The second example is a very smart application for automatic calculations from 3D models. The problem is very often to prepare right proposals because a lot of people are overloaded by preparing proposals. So we have, together with the company, made some special application where it is possible to import 3D step model. This step model is automatically analyzed and split to, for example, sheet metal parts and so on. And it's automatically counted length of the, for example, bends or cut lines. And based on this, there's prepared something like a list of processes which should be realized, including the distances and including cost and so on. So from 3D model, this company is able automatically in seconds to prepare very accuracy calculation for the proposal. So it eliminates work of approximately 4 people because automation is able to do it immediately. And of course, there is very accuracy related to the manual calculation and possible to make mistakes. So there were some examples from practical applications. Thank you very much for your attention. I hope this short presentation will help to understand how to digitally transform the company, and will also help you to find the proper technology for your digital transformations.